think it should.
No.
Did you have any? I didn't have the time to listen to the Friday recording yet. Was there any result that you?
There was a lot of fighting, but
No, because you weren't there, Felix.
Sorry.
It was no. I think it was useful in the sense we discussed a bit further what's a formula, and the notion that the formula is a distinct layer and has starting claims, and I've thought a lot about it since then, and I have new things to say, and I really want them to be here before I say it all. But the fighting was about, does the what is it that the formula, what's the output of the formula? I'm saying it's another claim, and Tim says it's not a claim because it's kind of uncontrovertible. Like, if these are the inputs, that's the result. And if you want to contest the result, you have to contest one of the premises.
All right, interesting. I would say there's no formula. There are only equations. Then there's no input-output thing. It's just relations between.
Yeah, I see what you're saying. He's thinking of it as input-output, but his point is there's this strong relationship, and that in a way cannot be contested or without contesting the formula. And what I'm saying is, yeah, sure, fine, but you still can contest the conclusion. Maybe that means that you have to contest one of the premises, or contest that this is the correct formula to apply, or contest, whatever. But you can still contest it independently. Say, no, this is not the correct conclusion. I don't know what's wrong with the premise, but okay.
You guys still talking about this stuff?
I just asked, like, what if there was?
Yeah. Basically, I recap for Felix, and of course, I gave a biased recap. I have.
Again, my opinion is there's no reason to do that. So I don't see it being a standalone claim, but we can go more into. I'm happy to continue this discussion today.
I've thought about it a lot, and I think I can recast it in less antagonistic terms. If you were,
I absolutely believe I understand what you're saying, and I get your point.
Good.
I think the difference is of opinion is whether or not that is at all interesting. It's yeah. Let me.
Okay, I have a long argument about this. If you're interested, I mean, I don't know who wants to begin. I mean, obviously you do too.
I think I would like to start by showing what I was trying. I tried to get some time to do this.
Excellent.
I got cut off by work stuff, as happens. And I'm still getting cut off. But what I did was I tried to work up a diagram.
Approved. I was going to say, let's get the diagram tool going.
Yeah, so I didn't get to finish it, but it's enough for us to start working with it, I guess, and talking about it.
Sounds good.
I just answered an important question somebody was stuck on. Am I able to share my screen?
You should be.
Let me see. Share screen. There's a button. Oh, there's the diagram. Okay. All right. So I kind of went with what we were more or less an example that we were looking at before, right? I tried to put it in F equals MA terms that would somehow be simple and somehow make some sort of sense. So I chose the stone is heavy enough to trigger the bear trap, right, as a claim, right? Yeah. So this is a discussion that not necessarily, but can involve F equals MA, right? For example, you can argue for or against it by saying, like, I saw someone try with a much bigger stone and it didn't trigger it, right? You can make that as a claim against it, and it's obviously not using any sort of science, right?
Except it was pumice.
Yeah, okay, yeah, exactly. Yeah, then you could argue for or against that. Well, what was the stone made out of, you know? The stone could have been made of styrofoam. It could have been at Disney. Okay. Anyway, so the thing is, it's a little hard to formulate this directly into an argument for or against using F equals MA. I realize what goes in between there is like a classic one is greater than the other, right? Which is, oh, one claim is how much force you need to trigger it, and the other is how much force the stone will be applying, right? So it's a greater than type claim. Used to support, right? It doesn't automatically prove anything. It's a support because obviously you can argue whether or not it's relevant, and you can argue the facts as well, right? So the downward force applied by the stone at rest on Earth, I'm being very specific, is greater than the force required to trigger the bear trap, right? You can even make an argument against this saying, yeah, but we're on Mars, right? So, but that doesn't invalidate this statement. It just says it's not important. It's not helpful. Okay, so then you come down to, you've got a claim that is a greater than situation, right? A is greater than B. Now, I think, again, even though we've talked about there being a logical structure in here inherent, and there are advantages to putting it in there somehow or whatever, you can still make arguments that are totally not mathematical or not connected to the logical A greater than B, right? I mean, there are a lot that say, that go up here because it's, you know, we're on Mars, it's inappropriate. But there could be, it's hard for me to think of one here, right? This is maybe too simple, but you know, you could make factual arguments without pulling together the mathematical equation on these things, right?
There's no arrows, so it's a bit harder to read. I'm assuming it always flows upwards, but I see the A and B arrows are flowing downwards.
Yeah, this is a different construct that's not in our model that I'm kind of making up on the spot. So
no, I understand. That's fine. But what you're saying is here the downward force supports the stone is heavy. That's fine. Now the A is greater than B is you kind of make it into a support link, whereas it feels to me that it's the interpretation of the downward force. I don't know if it's a support or if it's an interpretation. For me, those are distinct things.
Right. So what's going on here is in this approach, and this right here is not defining anything in here. Instead, what I'm calling this at the moment, and this isn't what it has to be, but one way I could see it being used is essentially we're trying to prove this by applying a formula, right? The formula being A greater than B. Now, it's true, it's inherent in the claim itself, and I haven't put it in the claim itself, and that is something that we should discuss further. In this approach, I just decided to say, okay, I'm going to prove it by making an argument that the force of A, which is a downward force applied by the stone, is greater than the force required. I mean, it could be A greater than or equal to B, technically. Yeah. It would be a separate formula, but it doesn't change anything here. Right. So like if I were to state this in words, I would say I'm making an argument that the downward force of the stone is greater than or equal to the force that we require to trigger the thing.
Yeah. So
that's all.
What we're saying is you have two base claims, the A and B claims, right? And you have the formula, and the way I was trying to say it is the formula yields and another claim, which is hence the downward force applied by the stone at rest on Earth is greater than the downward force required to trigger the bear trap. And that's the resulting claim of the A greater than B application.
Yeah, and that gets at the crux of what we're going to discuss. Stephen, you want to say something?
Yeah, at some point, it doesn't have to be now, but can you also elaborate on how this makes things more canonical? Because if I understood correctly, doing this is to make things more canonical, and I still don't see it, neither in the disagreement you two have, in neither what it should be. I don't understand the canonicality.
Okay, we should get to there. Let's one step. It may take more than one meeting to get there.
But it is the reason, right?
Is
this because if it's for a different reason than modeling something in a more
I'm not sure I would define it as more canonical, and that is something we need to explore. I haven't thought all the way to the end to know if that's the reason why. I know a different reason why.
Yeah, I know the different reason why as well, which was my suggestion for functions, which is more like, yeah, scoring. But my whole point was that the only
scoring.
Reason...
It relates to argument structure.
Yeah, this is not scoring. I agree with Tim here.
What I'm going to say is that it relates to the same thing that parameterization relates to. The main function I'm seeing at the moment is it allows us to reduce the explosion of claims and arguments.
But wouldn't that be canonicality? And if so, I want to see.
I'm not sure about that. Not sure about that.
Yeah, reducing explosion may not always take canonicality.
Because you could have, you could explicitly state every single variation of a parameterized claim, right? Like the cost to the economy is $1 trillion. The cost of the economy is $1 trillion and $1. The cost of the economy is $1 trillion $2. You could do that and it would still be canonical. Yeah, you just have an explosion of claims that isn't useful, right?
But there's still some confusion about what canonicality means. I'm certain we have different interpretations and goals of what a canonical form is. Well,
at the level of the claim, to me, canonicality means that a claim is unique. It's a singleton. And that begs the question of what is the essence of a claim, where my essence is the thing the claim is trying to represent, which I think is best represented and defined by definitions or disambiguations, right? So, you can see that the cost is $1 trillion versus the cost is $1 trillion $1 are two separate claims, right? So you have canonicality by separating the two separately.
So it is definitely different, because I would sum up my definition of canonicality, or at least whenever I use it, more as like I want one single place to model disagreements.
No, but it's the same thing. I think it's the same thing. But why do I want that to be canonical at all? It's because I don't want people making arguments in two different places on the same thing, which means you have to support canonicality of that thing.
True, but so in other words, if that's the goal, then we need to see how introducing this structure enables that, right? To see whether or not it enables canonicality. If not, apparently it does something different, and then I'd like to know what it does.
Right, and what I'm saying is maybe or maybe not it supports canonicality. Okay. Definitely, I see it supporting manageability of arguments. In other words, you can have canonical collection of arguments in a graph. We know that a canonical argument map is not a tree, it is a graph, right? We agree to that. Mm-hmm. The fact that it's a graph and the fact that you can make a support of two claims by saying like A is better than B, and then arguing against that support by saying no, B is greater than A, shows that you can have an explosion of arguments that I'm not sure the right words for this, but are useful and yet are not optimized for reading nor displaying nor managing.
I think I disagree at that point, and one of the results from the first study I ran was exactly that. Like, if the underlying disagreement in arguments is exactly that you're saying one person that's true, the other it isn't true. You're talking about the same claim, and that's why I group negation, and it's the same discussion.
It's not negation. It's not negation. It's when you have a solution space.
Okay. I have a lot to say.
Yeah, you start talking. I'm going to try to write out what I understood you saying about this generates a claim. I'm going to write out a claim that this generates that we can talk about.
And all that you're saying is relevant and important, both of you. And I don't want to say I don't want to negate it, and I want us to continue conversation. But what I want to put it in context. First, we agree that this function is another level and perhaps a separate domain. That's not the problem. What I'm realizing is this whole conversation about you cannot refuse the conclusion, and in that sense, it's not a claim without refusing one of the premises. That's what you said, Tim. And it is related to two fundamental concepts. One is the feasibility, and the other is this tying things together. And and by the way, before I get into that, before you arrived, Tim, Felix made an interesting point that maybe we should not think of formula as input-output, but as constraints, which would be multi-directional. And I think that bears thinking about. I still think about them in input-output, but I don't
understand that
equation. Instead of having like a function with parameters that returns something, you have an equation that relates things in a logical way.
So this means that you could attack it by either side. Like if I'm saying, and for me that makes sense. If you're saying A is greater than B is the result here, I could say, well, actually, A is true, A greater than B is true. What does this mean about B? Instead of saying A is true, B is true, what does it mean about A greater than B? You could attack it from either side because it's a relation. The flow of the feasibility can run in any direction.
I understand. It would be coming at the relationship between, the conclusion then would be part of.
We lost Stephen?
I don't know.
And what I'm trying to say is, if I think about it as a use case, the use case is we have this relationship between premise and conclusion, and again, maybe the directionality can be flexible, but the question is, what does it mean to disagree? It's about, what does a formula mean? It means that if we accept the formula in and of itself, there's something inconsistent about accepting the premise and accepting the conclusion. The question is, what does it mean to refuse the conclusion? It means either refusing the premises or refusing the formula as a whole. And this is the defeasibility point. And this is, in a way, what I was doing when I said, oh, it's a disjunctive normal form and it's a row. It's again saying, well, if you refuse the conclusion, you're either forced to refute one of the premises, that's what you're saying, or refuse the applicability of the formula. And perhaps by including a new defeater, like adding, oh, except here, except if this other condition, except if this other condition. But that's the generic use case. It happens all the time. And in a way, it made me think about negation in a new way. Because when I say this support, okay, first support. When I say this supports that, the question is, what happens when the conclusion of the support is defeated? Well, it depends on the nature of the support. If it was supposed to be absolute proof, well, it means it's necessarily one of the premise or the formula is defeated. But if it was just a generic support like induction, then maybe not. maybe it's just, okay, I may have to find a new explanation. In the case where it was, this happened because of that, well, maybe there's another reason why it happened. That's the case where the causality and epistemic are reversed. Maybe it means that, well, that example was an exception, an exceptional case, or low probability, or whatever, right? But there's two kinds of support. One where invalidating the conclusion invalidates either the support or the premise, and one where maybe it doesn't. It just makes it less relevant. And to come back to Popper, if we think of negation, like I'm saying, this is when we say there's this support claim, we often think in induction about, okay, what are the cases that support that conclusion? Well, in Popperian terms, we should say, what are the cases that refute it? So thinking about the negation of a claim as, let's look for defeaters. What would prove this false? And make that, actually encourage that process up to a point, because that's about encouraging scientific inquiry, right? Make it very explicit. What would make this false? So we lost you for a while.
Yeah, my battery is dead and I forgot to plug in my laptop.
Gotcha. I'll try to, I said a lot, I'll try to make it a very short version. When you have a support, whether it's backed by a formula or not, what it means is if you disbelieve the conclusion, that means you either disbelieve the premise or the support itself. And that's in a way what Tim was saying when saying you cannot refuse the conclusion without attacking the premises. That's what a formula is. It's making, you can also refuse the applicability of the formula, and that's what finding a new defeating argument is. Like saying this is not an applicable formula, you have to add the, oh, except if this, which is an alternate formula. You're adding a condition, a precondition. Or you're defeating the formula, but you have these constraints between the conclusion premise, which is the case for absolute support. And then we have the non-absolute support, where, for example, you have an example of a general rule where defeating the general rule, it might mean you need a new interpretation for the example, but it doesn't necessarily invalidate the example, right? But in the absolute support, the proof support, it means, like, the question is, what is the consequence of attacking the conclusion? Well, it means you have to either attack the premises or attack the relevance of the formula, maybe by providing a new formula with a new defeater. And this is really the pragmatic, it's the common use case we want to support. And the last thing I said is, we spoke of negation, maybe we should even encourage the Popperian attitude, which is, let's not think of proofs, but disproofs. How do you invalidate, how do you falsify a claim? And that means that think of the support as what would be the defeaters. That's slightly another aspect. But yeah, I wanted to recast the story as what happens when we do attack the conclusion.
But my question is essentially, is this conclusion that the function generates useful in any way except the fact that you're using it to support a claim or disprove a claim or whatever? Why would you argue against the downward force is 49 is greater than the downward force required of 25? Why?
Okay, that's not what I said. I said the downward force applied by the stone is greater than the downward force required to trigger the bear trap, which is pretty much your version.
It's my version, but I didn't need to generate a claim, and I don't want anybody adding or trying to refute this here. I don't see any discussion being required here.
This here is not
whether
something,
or not this formula is useful here.
No.
Right?
Okay. First, this thing you wrote recently is not something I proposed. It's not something I'm interested in talking about.
Sure. Okay, but
The-
how would,
what I'm saying is, it turns out that what would be generated by the function is equivalent to the your downward force argument. Now, which one would come first? In this case, it turns out that, and if we had canonicality, we could notice that the what is generated by the formula is equivalent to what you're trying to support, which is wonderful. Because it shows that the formula supports the or ties the relationship between the premises and the conclusion. For me, again, it's not, I wouldn't call it a support, I would call it a formula constraint relationship, right? But you'd need canonicality, because here you're presupposing that the argument was made independently, and then the A greater than B was applied, which would happen to generate the same thing. So this is, so either the system or a human has to say, well, what is the result of applying the formula is the same as the claim we were trying to support.
And then
or
we have
another
the equation.
The equation. Yeah, I'm using the term formula now. And our equation, no, you're right. Your term is, I like your term better. And so, which is another way of saying the equation is a interpretation of the original claim.
Just a more formalized version. And I would
except, yeah, but for example, I'm, in this case, you know, I would say, first of all, the formula I'm applying is not equivalent to the claim, because actually the claim is written as greater than, not greater than or equal to.
As
what I was going to, what I didn't get to do here was have the F equals MA example, right?
Doesn't add anything to the conversation, I think.
Well, it makes a more realistic example of what could be going on, because the downward force applied by the stone at rest on Earth is 49 newtons. Okay, so I say, well, look, I will prove that, and that is why you start introducing formulas, in my opinion, is I will prove this through math, right? I'm going to show you that mathematically this is true, and I'm going to use this formula, and we can debate separately these facts, but I plug it in and boom, right?
Can I suggest something? I would model it a bit differently when you scroll up a bit, that when you scroll, yes. The claim, the downward force applied by the stone, I would not say it supports the formula. I would put an equal sign into the formula.
It doesn't support the formula. I created a different type of connector here, where this is the relationship where this is the A of that function.
It somehow extracts the value from the claim.
Okay. Wait. I wasn't finished. I would put an equal sign into the formula, equal C, like A greater than B equals C. And then instead of having the green dot on the line to the other claim, it's just C. And then you don't have this whole supports thing, that the formula is not involved in the supports relation anymore. I think that
that's
makes
what I was saying. That's what I was saying.
Much more sense.
Okay, hold on, let me see you do that. Right.
I'm saying it's not a support. As
you would do what?
Into the A greater than B, you edit it and add equals C. And then instead of the green circle at the top, you replace that with an arrow that's pointing from the formula to the claim and says C. This is C.
But again, like the claim is not C here. The claim isn't C. C is 49 newtons is greater than 25 newtons. That's C. That's not these words that make up a claim.
No. Okay. There's
Because like I said, you can argue against whether or not this is true, right? Without having to have the C there.
Support relation from C to this claim, but not from the formula.
Because
this is about transitivity of equality, right? Downward force is 49. 49 is greater than 25. 25 is trigger threshold. So downward force is greater than trigger threshold by equality continuity. So the fact that 49 is greater than 25 is the near formula, but because of the other, and that's almost a separate thing, right? But the fact that you have these two equalities, those A and B are two equalities. And so I'm able to plug them into the 49 greater than 25 to get your claim C. Let's call it C. And
this here is C. This right here is C.
Yes, agreed.
That is C.
No,
and then
no, I don't think it
this
is.
C is supporting that. It is. Well, okay.
Okay,
I would just
say I also think it is, and I would like move the green circle away from the formula. It should not be connected to the formula. It should be connected to C.
I did that as an abbreviation for this is essentially a support claim made up of a function, right? But we could move it over here and say, well, it generates a claim, and then we're creating a claim. But again, I don't see any purpose whatsoever in debating this claim.
Okay,
That's
this claim has
I think
holes
this is a
first.
compound claim with no need for supports or opposes, right? The claim has holes. What are the claim holes?
There's dots, and I'm saying I disagree that this is the claim, and it's a bit hard to disagree when it's partial and the holes can mean anything.
Yeah, the dots are abbreviating it, and it's a hard statement to auto-generate here.
Okay. What I'm saying
well,
is,
that's because there's a lot of hand waving going on.
Yes,
that's true. That's true.
If you're saying it is, you do some magical calculation, which if you would implement it would mean that you need some formalization of the claims you're pointing to from your A greater than, which somehow magically knows a correct unit, which somehow magically, there's a lot of implementation work going on here, which is again my point. Why are we doing this? Because what do you gain? I still don't get it. And to structure arguments, sure, but to do what? I don't get it. Because does the formula live ever without the claims, or do they come as a whole? Can you reuse this formula? No. I mean, it obviously is directly linked to the claims, which somehow hold magical value you use in the computation. So what are you really doing? You're modeling
maybe
one calculation. You're modeling one mathematical calculation to do what?
Exactly. So that's the right question. And I think the motivation here by Timothy was that if you have claims that the stone has different weights, like 3 different weights.
Yeah, but model them in. How are you going to model it?
That's what I wanted to say. Like, let's add 3 claims that claim that the stone has 3 different weights and try to model that one, because that was the motivation, right?
The motivation, and it is a perfectly correct question, Stephen. What's the point? And I still think there is a point. Is that knowing that when the point as stated by Felix, if you contest the result of the calculation, you have to contest either the calculation itself, that is the formula, or the premise. Now, the formula, you would say, I think, the thing that I'll put words in your mouth, is could be entered as text, and it's valid. The question is, when is it useful to actually have a separate domain automating the relationship between the premises and the conclusion, rather than having the formula as text and letting humans do the formula? And I think it is mostly useful, I mean, it can be more or less useful in specialized subdomains. I don't think I need to argue that. But in our argumentation case, it's useful for applications of equality, of modus ponens, of like, this is where you're not following laws of logic. You're adding a defeater, so you have to know that this defeater needs now to be the contradicted, otherwise your thing doesn't hold. This is the case where I think the equation, and frankly, I do think that the A greater than B is a general case that belongs. When we argue over relative magnitude, it's a fundamental enough use case that being able to say, oh, does this new claim invalidate the A greater than B conclusion? If I say the value is this instead of that, which class of A greater than B gets invalidated by that new value? I think that's actually worth automating because it's frequent enough and it's fundamental enough. It's the transitivity of, it's about subsets, right? It's about saying, when are you escaping the subsets of cases that are covered by an argument?
But again, how is this not related to scoring? Because you have 10 competing stone masses. Like, how do you know which one to use? How do you know which one to plug into the formula?
The things you don't.
You don't.
Exactly.
Yeah.
No, but you know which ones you
would need a special kind of claim that functions as input. It has the
I would not let
data required for the input
or interpret anything. It's like all interpreted by humans.
I agree with that. Yeah.
You want to know which ones lead to contradictions. You want to know when does, oh, you have these 3 stones, and which of those 3 stones weight contradict the claim it's enough to trigger the bear trap. You want to know when you have painted yourself into a contradiction. And maybe the conclusion is, oh, we're not on the Earth, we're on Mars, right? So introduce a new assumption, introduce a new defeater, introduce a new formula, whatever. But what I'm saying is, you want to know, according to the assumptions that are here, I have these different claims. I'm not saying I'll know which one to plug. I'm plugging all of them and saying, okay, which ones lead to contradiction? And that's what I want to know.
Okay, but the formula in that case cannot, if you want to make this run and implement this, the formula cannot live without a reference to the entity and how to extract and measure what. So you need to model the entity within the formula. So it's not just an abstract formula, F equals MA, it's F of an entity. Yeah. And then out there's claim of entities and the value you're trying to extract. Otherwise, this is not going to work. So the formula is tied to entities. It has to be. Yeah.
Oh, yeah. I never thought any of this could work without entities.
That's what I meant with predicate logic, because if you have predicates, they basically extract stuff from like they're how do you say that? Predicates are Boolean logic, but you can plug in numbers, and these numbers need to come from somewhere. Yeah. And what I think the equations do is they relate stuff logically, but there are still numbers involved.
And we still agree, this is all optional, this is all a separate domain, and I'm all fine with that. I mean, I cannot dream of requiring this, but I think that making it possible is actually a very, very, very important use case.
Yeah. And I think it's important to say that this is a thinking tool for humans. This is not computers should evaluate the formulas or anything.
Fair enough.
Yeah, and it would only operate on the more formalized version. It cannot operate on you can't have a formula point to an informal claim, because that's impossible.
If it's if you have a logical formula, yes.
You basically need an entity, whatever. What did you call them, Antoine? You basically need entity has a value type of claims that are formalized, and then You can have formulas that indeed have like value extractions from entities.
Formal formula as opposed to text formula, as you've also been suggesting, which is also valid.
But only if it's the parametrized case.
Exactly.
If it's the logic case, you don't need a number.
Right.
If you relate things logically, like A and B equals C, then you don't need the parameters.
I'm making the argument that there's something between the full mathematizations F equals MA types and the purely logic case, which is the set subset, and where the greater than probably fits in this middle layer. But your mileage may vary on that. But I think it's a kind of intermediate case.
And nothing, when we look at the A greater than B thing, I would say it's a bit misleading in our discussion right now, because A greater than B is a predicate. And you can look at the whole thing as a Boolean variable. And if you want to decompose this Boolean variable, okay, you can say, oh, this Boolean variable is composed of A and B, and there's this predicate greater than, and we can go into more detail and then do things numerically. But what we're actually looking at is as the Boolean result of A greater than B.
And what I'm saying is we can think of it as set theory as well as math, and set theory is probably more generic and simpler in some ways.
Just wondering who's like actually a bit comfortable with predicate logic, like who, because I had it in university. So when we're talking about it, and Mark and Tom are probably assuming a lot of stuff, but
for me, it's ages ago.
Yeah, for me too, but like
I'm not sure the definition of it, so
okay, so maybe we should go over that you understand what we're talking about.
But I don't think we even need to. I mean, yes, but that's the thing with incremental formalization. We don't really need to, as long as we know where to place it. But I'd love to see the changes that you've been drawing, Timothy, because I think it's a bit clear to me now how I would implement it, which is the one thing I didn't get before. And I see how it supports a use case that Mike and Twan mentioned, where indeed you can find contradictions. Yes. So I can follow so far.
Yay.
Yeah, I mean, the fundamental problem that I don't feel has been solved yet is the explosion of arguments to the point of uselessness in this debate, given just the most basic informal structures. And the problem of, is this thing a supports or an opposes, you can't tell until you put two of them together, right? Because this alone, right, does this claim support or oppose this? It doesn't do either.
It doesn't. But this is where I think, again, thinking of it as a disjunctive normal form is extremely helpful. Like if you think of either, economic cost is this much and human cost is this much, that's a disjunction. That's one of the cases where it's true that A is greater than B. And you have a totally different case where this is the economic cost, this is a human cost, and again, A greater than B with totally different numbers. And again, this is, and each of these alone would support, but each of these is a disjunction, and the conjunction supports, but thinking about the components of the disjunction individually is meaningless. We have different scenarios, each of which support, but which are totally disjoint, right? And if you think of it as disjunctive normal form, it makes perfect sense.
So with just two values we're working with, we now have 4 arguments supporting or opposing this.
Yeah,
and
exactly.
no economic debate has only two values for each side, right?
Right.
And then you make arguments supporting one or the other. Well, okay, then we need this debate about what is the cost to the economy for the lockdown, right?
Yeah.
So that is a debate, and it's a debate with multiple outcomes. And you can argue it's 1 trillion because this model, and then you can argue that model is false because this model is better. And it says, no, circular reasoning. This argument is better. Just the debate over one value, if you don't have more advanced structures, will get out of hand. And then you are trying to put it together in this.
But this is why the internal structure of compound claims is important. It's because you're able to argue separately, is the cost of the economy 1 trillion or 2 trillion? And then it will automatically say, okay, among these conjunctive scenarios, these fall, right? Depending on this one. It's when you have the relation between the cost economy of 1 trillion supports 2 of the scenarios and opposes 2 of the compound scenarios, supports 2 and opposes 2 of the compound scenarios, then you can argue at the atomic level and not compare necessarily.
Right, but this is you're talking there about debating one of these instances, right? In that case.
What I'm saying is the debate, and there I'm with you, would not happen at the compound level. The support is at the compound level. The support to value of save is greater to the
right.
Is at that level. But the argument will only be done in terms of the atomic cost to the economy versus cost to the human lives. Those are, so you make the atomic arguments, which happen to have impact on a slew of compound models, which happen to then support or not support the final claim through the conjunctive normal form. It works.
Right, but it works. Of course it works. It also works to just write each one out by hand.
But
right?
we get the problem. We get what we're modeling. But can you move on to how you would then model it? So you're suggesting a structure.
Well, I'm bringing one realization to the table here, which is what I'm trying to figure out the right way to model, which has led to all of these things. Because really, these 4 options and the explosion of options you'd have beyond this all come down to 2 sides. The 2 sides being is whatever value I believe for the cost of the economy, greater than or less than, in this case would be, really the way it's stated is the value saved in human lives, whatever I believe it to be, greater than the cost of the economy, whatever I believe it to be. And so that's where you have a parameterized value of the cost of to the economy will be X. The value saved in human lives will be Y.
And that's what Marc-Antoine calls entities with posits and values, and so that overlaps.
And
but what happens then? Let me wrap this up here. Instead of having to go to every single variation and figure out what's going on in each one, you just focus on the debate of what you think the cost is going to be to the economy. And then you focus on what you think will be the value saved in human lives. And once you've got that, it proves it. And then you can focus on the debate of whether or not that's a proof.
Once all you have is a whole bunch of different numbers. The numbers are
and here's where once you've got that is a personal thing. Once you've got that is once you've stated I believe this one, I believe this number,
scoring,
I believe that number, or believe or whatever, right? You can call it scoring, but it's damn useful and important in this case.
Yeah, but whenever I say this is only useful for scoring, that's what I mean. This is only useful once you have an entity that has expressed belief or a value, or be it automated, be it human, then this is useful. Otherwise it isn't.
It's useful for consistency beyond that. The point is you cannot consistently believe cost to economy is 2 trillion. The human cost is 1 trillion. Cost to human cost is 2 trillion, and the value, the economic value is greater. It's about identifying when you're being inconsistent in your beliefs.
Yes. So because
it's not just scoring.
But that is what I call scoring. The calculating whether or not there's inconsistencies, you can only do if people start scoring, be it binary, be it like with degrees of how convinced you are.
It's separate from the question of canonicality. And I agree with that. We should have that discussion, because I think my understanding from Stephen's perspective is that the main issue regarding the core argument model is the support of canonicality. It may not be the only one, but it seems to be the one that floats to the top. Is definitely canonicality is in the first tier modeling requirements. Right?
I agree with that.
And scoring not. Okay. So the question is this necessary for canonicality? I don't think it is. I haven't come, because this claim on its own needs to be is possible to state, right? But also possible to state is A is greater than B. Okay, we know you can state that in words. Marc-Antoine raises his hand first. So.
Okay. Oh, you were done. I wasn't clear. Okay.
I was thinking, and I realized I didn't have anything useful to add. So go
ahead. First, I really want to say, for me, having the dependency graph between claims is totally distinct from scoring. Like, it's not about saying I believe this, I don't believe this. Is the belief in this is supported by that. And I agree it's not the same as canonicality, but I'm saying it's not the same as scoring. Scoring is about...
but that's not what I said. I said it's only useful for scoring. If the dependencies you model, they're only useful if you intend to do scoring. That's what I meant. I know that drawing dependencies is something different, but what I'm saying is you're drawing the dependencies because you want to use them while scoring. And if you never score drawing these dependencies, I don't know what for. If there's other use cases than scoring, I'd love to hear them, but I haven't heard any other ones.
Well, I think that the notion of is this consistent, is this not consistent, is not the same as scoring. It is the same as assigning truth values, but it can be at a personal level, it can be at collective level, it can be at no level. It can be the zero view, it can be universal view, but it's not. Can
something be consistent and not consistent without doing any scoring?
It can be done with assigning. It requires valuation, but I'm not sure valuation is the same as scoring, is what I'm trying to,
I think it is.
Okay, well, that may be a vocabulary distinction. For me, there's something I call scoring, which includes having kind of more absolute values as opposed to only ranking. I'm really interested in ranking, saying this is dependent on that, and so this is only as believable as the premise, without assigning a number to saying, scoring is about 0.5 and 0.2. For me, scoring, you're beginning to assign numbers and likelihood and degree of belief.
We've talked many times before about different, whenever we say scoring, I'm in the binary scoring camp, other people are in numbers.
And what I'm saying is I'm neither. It's what I'm saying is the dependency value and relative ranking of beliefs is neither numeric nor binary. It's something else again. So that's one thing I wanted to bring very much. Now, and I know, Felix, you've had your hand, sorry. The other thing where I spoke about conjunctive disjunction, it's true that when I'm doing that, I'm doing kind of each value is an independent claim. And the question is, can we make it a parametrized claim that is a single thing, yet acknowledges the containment relationships? What's the relation between all the specific value, 1 trillion, 2 trillion, and the abstraction of economic value of lockdown? That still requires thinking about. Over. Felix.
Okay, yeah. Something a bit different. While looking at the diagrams here, I had the realization that many things here are not claims. Like the blue boxes are supposed to be claims, but the ones with the X's inside are not claims. The value of a human life saved is X is not a claim. If you plug a number in, it becomes a claim, but in itself, it's not. And this way we were mixing up in the formulas, variables and predicates. We were mixing that up. So I think the equations or these formulas should only relate logic variables, which are claims, which can be parametrized, right? So basically the A and B here are it's basically A of X and B of X in the other box is something.
That's what I said before. It's like values of entities.
Yes, exactly. So the cost of the economy is X and the value of human life saved is X. These are not claims. You cannot argument against that. They only become claims when you plug in values.
They're claim formulas. They're predicate formulas.
Proper predicates, exactly.
They're predicate formulas.
Yeah. So
I agree totally.
we were mixing that up in the formulas a bit, and I think we should be more clear about it, because I think there's also a little bit of the confusion came from.
I agree with all of that. And actually, that wasn't even something I had realized until you went through the actual example. And I was like, yeah, you're right. I'm totally hand waving here. But so I need to think through it a little more. But yeah, I'm not sure. Yeah, examples help, I think. But yeah, I think I don't know. I don't know if canonicality plays into this. I think it's more advanced features in terms of simplifying the explosion of possibilities. But
the explosion of possibilities remains, but you can find internal conflicts more easily. Because I mean,
no, it only remains to the extent that you allow it.
Why do you add the cost? Why do you add the claims? The cost is the economy. Why do these live?
I think it's because the formulas allow decomposing complex claims and then arguing about against or for the parts of it. That's what the formula allows.
Yeah, essentially, if you accept, which is a separate debate, if you accept this formula as a valid structure that informs the debate, right? I think one of the key points here is that formulas aren't support or oppose.
I agree with that.
Whatever the outcome is, one side or the other, and
they can themselves
requires
be supported
a structure.
Or opposed, but
right. Or actually, it might be both. Well, anyway, that's a separate discussion we'd have to work through. But anyway, you've cut down the debate essentially to. I agree. If A is greater than B, this is interesting. And after debating, I agree A is this value and B is that value.
Where do you place these values? That's a key thing I still don't get, because that's you're trying to solve.
Well,
something.
You're right. We would need to connect
values.
it. It would require more formalization. It would require more formalization.
This entire thing relies on entities and values being formalized. Like the things being in the form. So
absolutely.
But then that works. Like Mike Antoine explained, if you have all of these, because they're formalized, you can easily connect them. Once you've expressed your opinion with one, you can easily find conflicts, blah, blah, blah. I get all that. But how does this result in what the user sees like in the argument tree, and how does it categorize it better than before without doing any scoring?
It compresses.
What the user sees is a UI thing.
Yeah, but what do they see?
But it's a compression. Instead of seeing the two texts, the value of human life saved is 1 trillion and the value of human life saved is 2 trillion. They just see the value of human lives is, and then the two values. Like it simplifies it removes redundancy basically.
And you can have a button to break out into the different proposed values. Right.
Okay. Yeah. But it's incremental formalization. So where does this get added? I mean, somehow.
Let me get into that because
I have a hard stop right now, unusually, because there's a new team member, and so we're doing daily stand-ups.
Okay, fair enough. So let that be. Do you mind it being the topic Wednesday? Tomorrow.
First of all, it's up to Felix, but secondly,
yes, let's do it.
Thanks for the example, Timothy. It really helped me understand a bit better. It was very useful.
Good. I'm glad I got a little time to try to work it out.
Yeah.
All right.
Great,
Then I'll see
great
you guys tomorrow.
conversation, folks. Thanks.
See you tomorrow.
Agreed.
Thank you.
See you tomorrow.
Are we all leaving, or do you want to give it a? Okay, we are all leaving.
Oh, we can wait, Stephen.
Yeah, but Mike Antoine already dropped out.
Yeah,
He was going to try to explain
conversation.
the UX part.
No, I just wanted to say, like, have a look at the 3 terminologies of predicate logic, which is like Boolean variables, or like Boolean. No, it's actually called predicates. Then you have the variables, which take numbers. Predicates have Boolean values, and the predicates. I'm sorry. So the predicates have Boolean values. They evaluate to Boolean values, and they can be parametrized with, for example, numbers. These are the variables. And I think what you were after is like, okay, like where are the variables in the UX?
No, not so much.
Thing.
What I'm after is, what is the relation between, I get the variables, and that's easy, that's UI, but what's the relation between the formalized form and the non-formalized form? Does it mean that, yeah, like how does this fit in? Like,
I would just say predicates have a sentence representation, if they're parameterized or not. If they're not, they directly evaluate to a Boolean value, then you can agree or disagree with it. And if they have a parameter, then people have to talk about the values of the variables, which can be numeric or can be anything else. But then with using the parameters, the variables, the predicate can evaluate to something.
Do you have any idea what it would look? Can you sketch something, just like a paper sketch, whiteboard sketch, something just to visualize what it would look like would help me a lot.
I can try. I'll see if I can do it.
Because I still don't see it. I get the whole. I learned a lot, but for me it's still scoring. But I see how it would work and how you would implement it, which is a big step from last meeting.
Yeah, I think it's just another modeling.
Yeah, concept. But I just don't see how it fits in the argument map.
I try to come up with something.
Yeah. Okay,
cool.
Thanks.
Yeah, thank you. See you tomorrow.
Yeah, bye.
Bye.